Net present value. In topic 1, we noted that the financial manager has three main roles. One of these was to make investment decisions, which means to decide which assets or projects the firm will invest in. And we noted that this type of decision would be covered later in the semester when we look at project evaluation. There are two other important types of decision making, but the investment decision is the focus of this topic. We are familiar with the concept of present value from the topic on financial mathematics. The value today of a future cash flow discounted using an appropriate discount rate. We saw in the previous topic that the appropriate discount rate to evaluate an investment project is the cost of capital. Net present value is just adding the present value of all positive and negative cash flows from a project, so that we finish up with the net difference between the two. Since, by definition, positive cash flows are benefits and negative cash flows are costs, we can also say that the NPV of a project is the present value of the benefits minus the present value of the costs. The concept of net present value gives rise to the NPV decision rule. In the topic on financial mathematics, we saw that a decision should be taken if the present value of the benefits exceeds the present value of the costs, because this will increase the value of the firm and the wealth of shareholders. We can see that this equation helps us to make investment decisions that increase the value of the firm. Project evaluation is used as part of the process of capital budgeting, which means determining how to spend the firm's available capital on investment projects. The goal of capital budgeting can be expressed in two ways: allocating capital to all projects that will increase the value of the firm, or to the project or projects that will increase the value of the firm by the greatest amount. These twin goals give rise to the NPV decision rule, which is just restating the goals of capital budgeting in terms of NPV. The NPV decision rule says that we should accept all positive NPV projects and reject negative NPV projects, or, when choosing between projects, accept the project with the highest NPV. Turning now to the calculation of NPV. This is a generic formula for the calculation, where C0 is the initial outlay, CT is the cash flow in period T or year T, N is the number of periods or years, and R is the cost of capital. This formula is using mathematical language to convey a concept, which is that the NPV of a project is the sum, where T takes on all values from 1 to N, of the cash flow in year T discounted to a present value minus the initial outlay. Often the only negative cash flow is the initial investment in the project, which occurs in year 0, so there is no need to discount the initial outlay, but we can and should discount all cash flows that occur in the future. However, any formula expressed this way is not of practical use for performing calculations. To put it into practice, we just have to take each future cash flow and discount it to a present value, using the formula for the present value of a future cash flow. We encountered this formula in the topic on financial mathematics. Then we add up all the present values and subtract the initial outlay. We can therefore express the formula this way: the present value of the first cash flow plus the present value of the second cash flow, and so on up to the nth cash flow minus the initial outlay. For example, we can calculate the NPV of a 4-year project using this version of the formula. What is the NPV of a project with the following cash flows if the cost of capital is 10%? We take each cash flow of $28, discount it by the appropriate number of periods, and subtract the initial outlay. Because the future cash flows are all the same, This constitutes an annuity. So an alternative way to calculate the answer is to calculate the present value of this 4-year annuity and then subtract the initial outlay. Recall the 3 critical factors in finance from the introductory topic. We can see that the NPV decision rule is consistent with all 3 critical factors. Only cash flows are included in NPV calculations. We take into account the time value of money because we discount all future cash flows to a present value. And risk is taken into account by the discount rate that we use. The greater the risk of the cash flows, the higher the discount rate and the less valuable the cash flows are in present value terms.